Hello, sir. Good afternoon. Am I audible?
Madam, good afternoon.
Good afternoon. Audible clearly?
Yes, yes.
Okay. Uh, so I think most of you have joined. Can we start now?
Yes, ma'am.
Okay. Thank you. So, if we will recap from the yesterday's session on your nature of science, understanding the science, we have discussed about the nature of science and also the aims and objectives of science. And we will start today from the learning objectives and how to write objectives and how to achieve the process skills and what are the shift in pedagogy of science. So these are these things we will discuss today. So, dear friends, we have also uh, discussed about the learning objectives yesterday. That learning objectives are the objectives that need to be achieved after the end of a lesson or a topic in the 45-minute period class. So, the learning objectives should reflect what the learners will do rather than what the teachers will do. That thing we have discussed yesterday. Learning objective that the learners will demonstrate, that is actually the shift what has happened in the science pedagogy. The proper use of verbs indicating learning process provides clarity and understanding of a learning objective. We all know about the verbs, and also there is a common name, that is the Bloom's taxonomy. When we will talk about the objective, then Bloom's taxonomy is there. So in 1956, B.S. Bloom, who classified the domains of human learning into three parts. One is your cognitive, affective, and psychomotor as the educational objectives. And Bloom's taxonomy is a model of classification of thinking. As a result of classification, a series of taxonomies was obtained in each domain that provided a means of expressing qualitatively different level of thinking of learners. Over a period of time, new ideas and insights emerged in order to reflect the change and to meet the need of 21st century learners. Anderson and Krathol, they revised the Bloom's taxonomy, and their result was published in the year 2001. Okay. So now what we are using? We are using or referring to the revised Bloom's taxonomy. And in the meantime, after 2001, a lot of changes has been occurred in the pedagogy. So if we will look into the Bloom's taxonomy had 6 tiers of learning, and they are arranged in a hierarchical way. With a little change in the hierarchy, the revised Bloom's taxonomy has also 6 tiers of learning that are more explicit. And the revised Bloom's taxonomy has two dimension, and the revised Bloom's taxonomy, which was done by the Anderson and Krathol, these two people were the student of B.S. Bloom. Actually, they were working with B.S. Bloom. So the revised Bloom's taxonomy contains two dimensions. One is your knowledge dimension, another is your cognitive process dimension. So if we will have a look on this, you can see the comparison here. This is actually the objectives are arranged or like a step of a staircase. When somebody is standing on the last last step, that is creating, then we can assume that all these steps has been crossed or achieved, all these objectives has been achieved by the learners. So you can compare these two also. In 1956, what is evaluation? Knowledge comprehension, application, analysis, synthesis and evaluation. And evaluation was the last step. And in 2001, in revised Bloom's taxonomy, the knowledge dimension is converted into remembering into the verb form. That means the students are going to do all this. The learners are going to demonstrate. That's why remembering, understanding, application is like applying, analysis is analyzing, synthesis is creating, but evaluation is evaluating. These two steps are interchanged among themselves. So the revised Bloom's taxonomy differs in three ways. How they differ? They differ in terminology. As we see in the diagram, they differ in the terminology. Noun to verb, there is a shift. Synthesis to evaluating and evaluation to creating. That is already demonstrated in the figure. Then structure. Structure is changed from one dimensional to two dimensional. The previous Bloom's taxonomy, what is there in 1956, that was one dimensional only. We were talking about the knowledge, comprehension, etc. This was one dimensional. But here it is converted into a two dimensional form, the structure. And another part, third part of the difference in the third area is the emphasis. Emphasis here in the revised taxonomy, emphasis is more on description of subcategories of learning. So in the next slide we will see what are the subcategories of learning. More emphasis was given on the subcategories. So first let us see and discuss about the two-dimensional process. One is the knowledge dimension. See here the knowledge dimension, and another is the cognitive process dimension. The knowledge dimension include the factual knowledge, conceptual knowledge, procedural knowledge, metacognitive knowledge. So again, each knowledge dimension has a process dimension, cognitive process dimension. Then cognitive process dimension include all these six criteria or six steps, you can say. So every knowledge dimension has these six areas. For example, the fact, knowledge about scientific facts. Knowledge about factual knowledge means knowledge about scientific facts. So if we will take one example of scientific facts, then facts have again six areas. One is your remembering what fact the students will remember. That is the remembering. Then understanding, applying, analyzing, every aspect will be there. For example also is there. So for example, knowledge dimension, if one example is given here, how we can write this, how we can perceive this dimension. Suppose here in this example, knowledge dimension is taken, and one of the knowledge dimension is also procedural knowledge. Then if we will take the knowledge dimension as procedural knowledge, then what will be the learning objective? For example, here we have taken one example of making a simple torch. And the third column represents the cognitive process dimension. So here the knowledge dimension one and second one is the cognitive process dimension, and in the middle we have to fix our objective or decide our learning objectives. So let us take the example making a simple torch, recalling the required electric circuit diagram. If you are teaching in the class about the electricity chapter and electric circuit diagram is taught to the learner, then when they can make a simple torch, recalling what? Recalling is the dimension, the emphasis part को मने पकाନ୍ତୁ सेठी कोन थिला ना the stood emphasis is given on the subcategories of the cognitive process dimension. So recalling is a subcategory of cognitive process dimension. Remembering has two subcategories. One is your recognition or recognizing, and next is your recalling. So if the learner is able to make a simple torch, recalling what? Na recalling the circuit diagram. Electric circuit diagram ତାକୁ class ରେ ପଢା ଯାଇଛି ଆଉ ସେ ତାକୁ ଯଦି recall କରିକି simple torch ଟେ ବନେଇ ପାରୁଛି, that will be your objective, and that objective will be considered under the cognitive process dimension, remembering. Now the thing is clear, I think. Remembering, the student will remember the circuit diagram only, and recalling the circuit diagram he can make a torch. Then another objective example is explaining how does the bulb glow, indicating the direction of flow of electric current. If the learner is able to explain how the bulb glow and he is able to indicate the direction of flow of electric current, then we can say that which process dimension is achieved. Now the understanding process dimension is achieved if this type of thing you will consider as your objective. But your knowledge dimension is same, the procedural knowledge. Here we are talking about the procedure, how to use the knowledge of the procedure, the steps. By taking this dimension, we can fix our objective in all these 6 categories of cognitive process dimension. Then if you will consider to the proceed to the next step, then if the child is able to relate, so the relating glowing of the torch with a closed electric circuit, then it will be referred to as applying cognitive process dimension. ଯେତେବେଳେ ସେ ରିଲେଟ୍ କରିପାରିବ ଏଇ ଗ୍ଲୋଇଂ କାହିଁକି ହେଉଛି ଟର୍ଚ୍ଚର ଗୋଟେ କ୍ଲୋଜ୍ ସର୍କିଟ୍ରେ, ସେଇଟା ଯେତେବେଳେ ସେ ରିଲେଟ୍ କରିବ ତାକୁ ଆମେ ଆପ୍ଲାଇଂ ଡାଇମେନସନରେ ରଖିପାରିବା. ଓକେ, ଦେନ୍ proceed to the fourth step, that is your identifying problem in the electric circuit or components. If the bulb does not glow, then it comes to the next higher form of objective, higher form of process dimension, that is identifying the problem. If the learner is able to identify if the bulb does not glow, se circuit बनेदेला परे bulb glow करू नाही, सेतेबेले से सर्किट डायग्राम पढ़ी, सर्किट डायग्राम रे कौन कौन रुहे, केमिति कनेक्ट हुए से पढ़ी सारा पर से करी सारा पर देखुची जे द बल्ब डज नॉट ग्लो. At that time, what he will do, if he is able to identify the problem, where is the problem, then this is the analysis part, analyzing. That means the cognitive process dimension is analyzing. He is able to analyze the problem, analyze different parts, and he will be able to solve the problem. Then we can say that the learning objective, identifying problem in the circuit, is achieved. Then next one is your selecting suitable electric cell and bulb from a given assemblage for making torch by checking their specifications. If this part will be done by the learner, then we can say that our cognitive process dimension evaluating is achieved. Yes or no? If you will face any difficulty, you can ask question by unmuting yourself. Okay. Next, next dimension, the higher form, creating. Then modifying the structure of electric circuit of a simple torch or making a device using simple circuit will be your creating. Okay. Now you understood. Knowledge dimension ଆମେ ଗୋଟେ ନେଲେ procedural knowledge. ତାର ସେକେଣ୍ଡ ଡାଇମେନସନ୍ ହେଉଛି କଗ୍ନିଟିଭ୍ ପ୍ରୋସେସ୍ ଡାଇମେନସନ୍। କଗ୍ନିଟିଭ୍ ପ୍ରୋସେସ୍ ଡାଇମେନସନ୍ର ଛଅଟି ସାରା ଷ୍ଟେପ୍, ଛଅଟି ସାରା ଟର୍ମର ଏକ୍ଜାମ୍ପଲ୍ ଦେଇକି ଆମେ ଏକ୍ସପ୍ଲେନ୍ କଲେ ଯେ ହାଉ ଟୁ ଲର୍ଣ୍ଣିଂ ରାଇଟ୍ ଲର୍ଣ୍ଣିଂ ଅବଜେକ୍ଟିଭ୍ସ, ହାଉ ୱି କ୍ୟାନ୍ while we will plan a lesson, then how we will deal with the learning objectives. Next we will discuss what are the categories of cognitive process and what are the subcategories. Learning action or the action verb, which is the most important thing for you, that we will discuss. Then the category of cognitive process, we know that remembering is a category of cognitive process. So retrieving the relevant knowledge from memory is called remembering. Yes. Then what will be the subcategory? Subcategory will be recognizing, recalling, or finding. Finding means finding from a list or finding from a given area, given subject like this. This is finding. So specially this is recognizing, whether we are able to recognize it or not, and recall it. That means we are retrieving from the memory what is there in the memory. Then learning action or the action verbs are recognizing, retrieving, finding, listing, naming, selecting, stating, defining, describing, identifying, labeling, recalling, locating. All these action verbs can be used. When you will use these type of action verbs in your objective, in writing your learning objective, then it can be understood that you are indicating to the category of cognitive process, that is your remembering. So if you are teaching a concept, then the things related to recognize, retrieve, find, list, state, define, describe, etc., these are the learning action verb. These are the action verb ବୋଲି ଆମେ ତାକୁ କହିବା. Next is your learning product providing learning evidence. Product କ'ଣ ହବ ସେଥିରେ ନା definition. The learner will define the terms. They will recall and recognize or recall the definition or the fact, or they can do worksheet or list something or label something or recall something. Then this is remembering part. Then next is our understanding. Understanding category ଭିତରେ cognitive process କ'ଣ ରହୁଛି ନା constructing meaning from the teaching learning materials and processes, getting involved in oral, written and graphic communication. କିଛି ବି ୱେରେ ହଉ ସେ କନଷ୍ଟ୍ରକ୍ଟ କରିଥିପାରୁଥିବ ଯଦି ମିନିଂ ଆଉ ତାର ମେଟେରିଆଲ ପ୍ରୋସେସ ଏଗୁଡ଼ିକୁ ସେ ବୁଝିପାରୁଥିବ, ଦ୍ୟାଟ୍ ଇଜ୍ କଲ୍ଡ ଅଣ୍ଡରଷ୍ଟାଣ୍ଡିଂ. ତ ଅଣ୍ଡରଷ୍ଟାଣ୍ଡିଂର ସବ୍ କ୍ୟାଟେଗୋରୀ କଗ୍ନିଟିଭ ପ୍ରୋସେସ କ'ଣ ରହୁଛି ନା ଇଣ୍ଟରପ୍ରିଟ କରିପାରିବ, ଏକ୍ଜାମ୍ପଲିଫାଏ ଏକ୍ଜାମ୍ପଲ ଦେଇପାରିବ, କ୍ଲାସିଫାଏ କରିପାରିବ, ସମରାଇଜ କରିପାରିବ, ଇନଫର କରିପାରିବ, କମ୍ପେୟାର କରିପାରିବ, ଏକ୍ସପ୍ଲେନ କରିପାରିବ. ସୋ ଅଲ୍ ଦିସ୍ ଆର୍ ଦ ସବ୍ କ୍ୟାଟେଗୋରୀ ଅଫ୍ understanding. And what action verbs you can use? You can use explain. The child will explain, the learner will explain the process, interpret the result, interpret from the examples, summarize the content explained, give examples or exemplify, compare. What is the difference between these two? This type of comparing will be there. Then predicting or giving example. One concept is like this. So if he understands, then he can give example or predict. Estimating, classifying, paraphrasing, inferring, all these things can be used as action verb for understanding. And learning product will be like this. The learner can describe, explain, or prepare a report, prepare a diagram or graph or quiz, or collect some related information, or they can demonstrate. The next is your applying. Applying means using strategies, concepts, principles, theories, and procedures in new situation. Learning in one area, one situation will be transferred and applied in different context. Then it is applying. Then its subcategories are executing and implementing. Implement action verb হচ্ছে implementing, executing, solving, relating, demonstrating, preparing, modifying, showing, using, applying, manipulating, computing, participating, all these things. So these action verbs need to be used while making your lesson plan, so that you can indicate that this is our learning objective, and this learning objective refer to applying. That's why this is important for you, because you are going to apply this in your lesson plan while doing the lesson plan. Next category is your analyzing. The meaning of analyzing is actually the breaking down knowledge into its components and determining the relationship of components with one another. You will take one concept. Suppose you are teaching the photosynthesis, then what are the different components of photosynthesis? If the learner is able to break down it and determine what is the relationship between the light reaction, dark reaction, or chlorophyll, sunlight, all these components, among all these components, then it is analyzing category. Then its subcategories are differentiating, organizing, attributing. Then learning action or action verbs you can use. The learners can analyze, or can it is analyzing the components of this thing or that thing. Like this, you can take your action verb. Comparing, you are teaching the reproduction in animals, they are comparing the unicellular and multicellular, the difference, or comparing the reproduction in unicellular organism and multicellular organism. So this is comparing. Breaking down into different parts. For example, what example we have taken in the previous slide, that you will give them a torchlight and ask them to break it down to different functional components or functional parts. Again, they will reassemble. That will be your evaluating, but here analyzing, they can break it down to different functional parts. Then structuring, integrating, separating, organizing, distinguishing, illustrating, attributing, outlining, or making diagram, or inferring, all these will be analyzing action verbs. Similarly, if you want that your students will evaluate or achieve the evaluating means that we have to judging the value of ideas, whatever is taught, whatever they learned, whatever knowledge they constructed in the classroom, they will judge the value of ideas, materials, and methods by developing and applying standards and criteria. At that time, we can say that evaluating step or evaluating objective is achieved, and its subcategories of cognitive process are checking, critiquing. ଯେତେବେଳେ ଗୋଟେ ଆମେ କନସେପ୍ଟ ପଢୁଛୁ ଫ୍ୟାକ୍ଟ ପଢୁଛୁ ତାକୁ ଆମେ ଚେକ୍ କରିବା ଯେ ଆମେ କ୍ରିଟିକିଂ କରିପାରିବା ଯେ ଏଇଟା ଏଇଭଳି ହେଇନଥାନ୍ତା ବା ତା ଉପରେ ଆମେ କମେଣ୍ଟସ୍ ଲେଖିପାରିବା ଜଜମେଣ୍ଟ ଦେଇପାରିବା ତାକୁ କ୍ରିଟିସାଇଜ କରିପାରିବା ବା ଚେକ୍ କରିପାରିବା ହାଇପୋଥେସାଇଜିଂ କରିପାରିବା ବା ଏକ୍ସପେରିମେଣ୍ଟ ତାକୁ ନେଇକି ଆଉ ନୂଆ କରିପାରିବା ତାକୁ ପ୍ରୁଭ୍ କରିବା ପାଇଁ ଜଷ୍ଟିଫାଏ କରିପାରିବା ଡିଫେଣ୍ଡ କରିପାରିବା ସପୋର୍ଟ କରିପାରିବା ସୋ ଦିଜ୍ ଆର୍ ଦ ଇଭାଲୁଏଟିଂ ପ୍ରୋସେସ୍. So the action verbs are judging, checking, criticizing, evaluating, hypothesizing, experimenting, testing, monitoring, appraising, justifying, like this, explaining, relating, interpreting, declining, deciding, everything comes under the evaluating process. Then next is your creating, which is the higher form of objective, and the last step in the hierarchy, that is your creating. Create means putting together ideas or elements to develop an original idea or combining elements, forming coherent or functional whole of ideas and products, engaging in creative thinking. So, when you are teaching a concept, at that time, after completion of your teaching or knowledge construction or exploration process, the learner will be able to put together all the elements, analyze, evaluating pore, they will be able to put together all elements and can create something, design something, construct something, or plan, or it can generate new ideas. At that time it will be referred to as creating. So the subcategories of cognitive process of creating are generating, planning, and producing. So action verb what can be used, that is your designing, constructing, reconstructing also is under creating. Reconstructing means he will break down it, then reconstruct it. Then so reconstructing is also creating. Reconstructing in a new way, different way. Then inventing something, making devices, planning, producing, generating, recognizing, composing, modifying, etc. So these are the action verbs while writing a learning objective. Okay. Okay. Then writing objective. So we will take some more example. So remembering, we know that learners recalls and recognizes fact, definitions, laws, principles from the memory, and it helps the learners in understanding science. Example, learners of chemistry can be given different prefixes to enhance their science vocabulary. This is also remembering part. You can take the activity like this. You can take a word and ask them to write. Science language is also important in science, and also in bioscience part also the language is much more important. So let the learners learn the science language also. This can be a remembering part. Next is your example of learning objective for chapter lens. I have given examples here. If you will write like this, identifying convex and concave lenses by touching them and observing images, recalling the definition, you can mark the action verbs used here. Remembering ରେ ଆମେ ଏଇ ସବୁ action verb ଦେଖିଥିଲେ ଲେଖିଥିଲେ ସେଠି, ତେଣୁ ଏଇ action verb ଗୁଡ଼ିକ ଆମେ remembering ଲେଖିଲା ବେଳକୁ ୟୁଜ୍ କରିକି ଲେଖିବା ଯେତେବେଳେ ଆମେ objective ଲେଖୁଥିବା learning objective lesson plan ରେ. So identifying convex concave lens, ଆପଣ concave convex lens ପଢଉଛନ୍ତି, ତ if the child will be able to identify the lens by touching them, ଏଠି ଆମେ ଟିକେ specific ଲେଖିବା, objective ଲେଖିଲା ବେଳକୁ it will be specific. Specifically, it is mentioned here that identifying convex and concave lens by touching them. ଧରିକି ଆମେ ଜାଣିପାରିବା ଯେ which is convex and which is concave, and observing images formed by them. ତା ଦ୍ୱାରା ଯୋଉ ଇମେଜ ଫର୍ମେସନ ହଉଛି ତାକୁ ଦେଖିକି ବି ଯଦି ପିଲା ଆଇଡେଣ୍ଟିଫାଇ କରିପାରୁଛନ୍ତି ଯେ ଦିସ୍ ଇଜ ଏ କନଭେକ୍ସ ଲେନ୍ସ, ଦିସ୍ ଇଜ ଏ କନକେଭ୍ ଲେନ୍ସ, that we can say that this is the remembering objective. Then recalling the definition of real and virtual image. You have taught in the class, and if they will recall and remember the definition, then also it is your remembering objective. Then stating one situation where virtual image is formed, listing two uses of each of convex and concave lens. This is also this can be written in your remembering objective. These are the examples how to write the objectives in under different categories of cognitive process domain. Then if you will proceed to the next step, that is your understanding part, learners construct meaning in various teaching learning situations. She understands if she can correlate and connect different concepts and bits of knowledge. ଆପଣ ଗୋଟେ ଏକ୍ସାମ୍ପଲ ପଢଉଛନ୍ତି ଯେ how photosynthesis occurs in plants. How type, if you is able to explain the how type question, that is your understanding. So examples are how to write. So chapter photosynthesis, describing the process of photosynthesis. If the child is learner is able to describe the process of photosynthesis, then understanding it can be said that this is the understanding objective. Summarizing various steps involved in photosynthesis. Distinguishing light and dark reaction of photosynthesis. Distinction. Illustrating the need of chlorophyll for the photosynthesis. So all these type of these action verbs when used to write the objective, that is your understanding objective. Next is your applying. So learners can use facts, concept, principles, theories and solve problems in new situation. What the learner construct in the classroom, what knowledge he acquired, which objectives he achieved in the classroom, if you will be able to apply it in different situation or new context, then we can say that this is applying. For example, you are teaching them the natural resources, and if they are convinced that or achieve the objective that natural resources, water is also a natural resources and water need to be conserved, as we are facing different problems in our daily life, how water crisis, we are facing water crisis, and when the learner when using it in school tap, this concept when applied while using the water tap of school, then we can say that applying objective is achieved. And some examples are given here. So we can write in this way that predicting the consequences of absence of chlorophyll in plant. ଯଦି ଆମେ ଏଇଭଳିଆ ଅବଜେକ୍ଟିଭ ପ୍ରେଡିକ୍ଟ କରିପାରିବ ପିଲା ଯେ ଯଦି କ୍ଲୋରୋଫିଲ୍ ଏବସେଣ୍ଟ ରହେ ପ୍ଲାଣ୍ଟରେ ତାର କନସିକ୍ୱେନ୍ସେସ୍ କ'ଣ ହବ ସେ ପ୍ରେଡିକ୍ଟ କରିପାରୁଛି. ସୋ he is applying he is able to apply the knowledge. Perform an activity to demonstrate the importance of sunlight for photosynthesis. Activity ଗୋଟେ perform କରିପାରୁଛି, then also it is applying. Then next is your analyzing. The learners can see patterns, recognize inherent meaning and identify components. That is analysis. We generally know the term analysis, but how we will use this in science teaching. So at the level of analyzing, the learner is in a position to compare attributes, organize, breaking down knowledge into its constituents. The learner can analyze a situation. He can establish relationship between different components. Analogy can also be used to enhance their understanding. The structure and function of the eye, for example, can be compared with a camera. ଯେତେବେଳେ ଆମେ ଏନାଲାଇଜିଂ ଷ୍ଟେପ୍ କଥା କହିବା, ଆମେ ସେତେବେଳେ କ'ଣ କରିବା ନା, ସପୋଜ वी आर टीचिंग द टॉपिक structure of eye. Then in eye there is lens, and in also he has learnt about the lenses. So when he is able to compare these two or analyze these things, that there is also lens, there is also lens, which type of lens is this, what type of lens is this, how it is functioning, how the reflection process occurs here. So all these things when the child is able to do, then we can say that analyze objective has been achieved. So the structure and function of eye can be compared to a camera. While transacting the concept of lens in physics, the lens of eye can be compared with the image formation by the convex and concave lens of a camera. That means here this is your extension part. You are extending your content to different area, different area, so that the students can link the concept. When the student is able to link, then only learning will be possible. For example, you're organizing, some examples are here, but you can make your own on the basis of your topic. So, organizing the events of photosynthesis, relate photosynthesis with fruit food production. So, these are the analyzing part. These are the higher form of objectives. The next is your evaluating. The learners can evaluate, generate, critique, judge, formulate hypotheses of scientific concept and plan experiments. At that time, evaluating, they are evaluating, they have developed everything, and now they are judging, they are critiquing, they are giving their judgment, they are producing their ideas on that particular thing, they are evaluating the thing whether it was good or bad, they are adding some value to it, then it is called as evaluating part. They can justify a decision, why I have taken this decision, they can justify, then it is called as evaluating. And some examples are commenting on the trend of reproduction process in animals starting from prokaryotes to eukaryotes, how it is occurring from. They have taught about the reproduction in prokaryotes, unicellular, multicellular, like this in a hierarchy. And when they are able to evaluate it, judge it, comment on it, how it is occurring, whether it is through asexual reproduction in prokaryote or eukaryote or unicellular or multicellular, like this, then when the comment will be there, then it is you're commenting on the trend of production, then it is evaluating step. That means the student has reached the fifth step of the hierarchy of revised Bloom's taxonomy. Okay, then next is your, suppose justify a statement. You can give a statement, amoeba is immortal, justify. This is also related to your this chapter, reproduction. So if the child is able to justify it with appropriate reasons, so that he is evaluating. So evaluating the environmental consequences of increasing demand of energy. Next, and the higher step is the creating, designing, planning, constructing, writing, and producing through one's own imagination. That is your creating part. Sure, examples are conducting a survey on the awareness of people about sources of air pollution in their localities. You are teaching the air pollution, but we are not reaching to generally the creating part. Air pollution is in science teaching. So this example also we will take while we will discuss about the shift in the pedagogical process. Pedagogical process रे कौन shift ହେଇଛି ଆମେ classroom ରେ କେତେ ବାଟ ପର୍ଯ୍ୟନ୍ତ ନବା କଥା, this ଏଟା science teaching ଆଉ generally classroom ପର୍ଯ୍ୟନ୍ତ ଆଉ limited ନାହିଁ. What is science ରେ ଆମେ ସେ କଥା discussion କରିସାରିଛୁ. So conducting a survey is also, you can take the objective in creating step. So if the child is able to conduct a survey by its own on the awareness of people about sources of air pollution in the locality, and enacting a play showing structure of solar system, you are doing the science act, science play. So if the students are able to do these things also, that means they are creating, they have achieved all the 5 steps, 5 objectives, and they are in the 6th step, that is your creating step. So who is in the hierarchy? The people who are in the hierarchy last step re jo mane achanti, they are supposed to achieve the all the lower objectives. Otherwise they cannot move to the higher objective. Higher objective je achieve करछि माने से lower गुड़िक निश्चित भाବରେ achieve କରିछि. Okay. Next, जो shift कथा हमें कहतलु, what are the shift in pedagogical approach? So, what we have discussed in the previous class also we have discussed, actually the shift started from the NCF 2005. So, there is actually a shift from understanding science as a collection of facts and principles to constructivist and inquiry oriented learning experiences, taking learners at the center of the process. So, this shift is from teacher to learner. That is the shift. And the role of classroom discussion in promoting critical, creative, and reflective thinking of learners and collaborative participation in the classroom have been identified as being centered to the construction of their knowledge. Okay. ତେଣୁ ଆମେ ଏଇଟା କହିପାରିବାନି ଯେ ଏଥିରେ ସିଫ୍ଟ ହେଇନି ଏନସିଏଫ ଯେତେବେଳେ ଆସିଲା ସେ କହୁଛି ଆମେ ସିମ୍ପଲ ନୋଇଂ ଦ ଫ୍ୟାକ୍ଟରୁ ସିଫ୍ଟ ହେଲେ ଆମେ ଧୀରେ ଧୀରେ ସିଫ୍ଟିଂ ପ୍ରୋସେସ ଚାଲିଛି वी आर कंटिन्यूइंग और वी आर इन द सिफ्टिंग प्रोसेस क्लासरूम डिस्कशन रे आउ एतिपाई करा जाउनी जे नॉलेज ट्रांसफर ऑफ नॉलेज फॉर ट्रांसफर ऑफ नॉलेज पई एटा आउ करा जाउनी नॉलेज टाको आमे केवल ट्रांसफर करबा सी सेंस रे आउनी आउनी साइंस को एबे बुझा होची जे साइंस इज नॉट द ट्रांसफरिंग ऑफ नॉलेज फ्रॉम वन जनरेशन टू अनदर साइंस कोन ना साइंस नीड्स creative thinking, needs critical thinking, needs reflective thinking. So it is also focused very much in the NEP 2020 on the reflective thinking of learner. ना कि टीचर पढ़े देथिबो पिला माने करो किछि थिंकिंग प्रोसेस डेवलप है नथिबो that is not science teaching in the classroom. So we have shifted from a rote type or transfer of knowledge type situation or ताको हमें कोइ परिबा acquisition of knowledge type रू हमें आसीचु कोटी केबे ना towards the construction of their knowledge. So in the present age is called as the globalization age. And in the globalization age, the information and communication technology has directly or indirectly affected our education system. This is one of the example. You are there at your home and learning science through technology. So the pedagogy of science from this point of view deals with the strategies of teaching learning, organizing classroom experience, knowledge about preconception of learner, and transacting the concept to diverse group of learners relating to their preconception so that they can assimilate and accommodate new information to make meaning of it. Okay, so we need to recognize that potential of the learner. What is their preconception, what is there in their mind, that the teacher has to take into account what is the preconception of learner, and by taking their experience we have to organize the classroom experience, otherwise it will not be fruitful. So if we will do this, they can assimilate and accommodate new information to make meaning of it. For example, I am giving you one example. Suppose, as all of you know that according to RT, Right to Education Act, the students up to age 14 can be taken admission to the age appropriate class. Yes. So, suppose for yes.
मैडम को चैप्टर टा पढ़ा होचे यूनिट केते
এটা pedagogical shift ଆପଣଙ୍କର ଅଛି, ଏଇଟା ଆପଣଙ୍କର 4 ରେ କଣ୍ଟେଣ୍ଟ ଅଛି, କଣ୍ଟେଣ୍ଟ ସହିତ କଣ୍ଟେଣ୍ଟ କୁ ଆପଣ ମାନେ କେମିତି ଟ୍ରାନଜାକ୍ସନ କରିବେ ସେ
ଆଜ୍ଞା
ଦିଟାକୁ ମିଶେଇକି ଆପଣଙ୍କୁ 1 ଆଉ 4 ଟାକୁ କୁହାଉଛି ହେଲା, 2 ଆଉ 4 ସେ କାଲି ସରି 2 ଆଉ 3 ଆଉ ଜଣେ ମ୍ୟାଡାମ ନେବେ ସେ କାଲି।
ଆଜ୍ଞା ଆଜ୍ଞା ମ୍ୟାଡ଼ାମ, ହଉ ମ୍ୟାଡ଼ାମ,
ଓକେ,
ଥ୍ୟାଙ୍କ ୟୁ।
ତ ଏଇଟା pedagogical shift ଆମେ ଡିସ୍କସନ କରୁଛୁ, ଏଇଟା ସେଇ ବ୍ଲକ୍ 1 ରେ ଅଛି ତାର ଥିଓରି ପାର୍ଟଟା, ଆଉ ଟ୍ରାନଜାକ୍ଟ କେମିତି କରିବେ ୱିଥ୍ ଏକ୍ସାମ୍ପଲ ଆମେ କହୁଛୁ କଣ୍ଟେଣ୍ଟକୁ ନେଇକି। ଓକେ
ଓକେ ମ୍ୟାଡ଼ାମ।
ଓକେ, ଥ୍ୟାଙ୍କ ୟୁ। ଓକେ, ତ ଆମେ କଣ କହୁଥିଲୁ ଯେ ଗୋଟେ ଏକ୍ସାମ୍ପଲ ଆମେ ନଉଥିଲୁ ଯେ ଆମେ ଯେତେବେଳେ ଗୋଟେ ପିଲା କ୍ଲାସ ରୁମକୁ ଆସୁଛି ତା ପାଖରେ ପ୍ରି କନସେପସନ କଣ କଣ ଅଛି, ଆମେ ସିଫ୍ଟ କଥା ହଉଛୁ ଯେ ହାଉ ଦ ସାଇନ୍ସ ଟିଚିଂ ହେଜ୍ ବିନ୍ ସିଫ୍ଟେଡ୍। ଆପଣମାନଙ୍କ ଟ୍ରାଡିସନାଲ କ୍ଲାସରୁମ ରେ କଣ ଥିଲା ନା, ଟ୍ରାଡିସନାଲ କ୍ଲାସରୁମ ୱାଜ ଟିଚର ସେଣ୍ଟର୍ଡ। ଆମେ କହିଲେ ଯେ ଟିଚର ଠୁ ଲର୍ଣ୍ଣର ପର୍ଯ୍ୟନ୍ତ ସିଫ୍ଟ ବର୍ତ୍ତମାନ କେମିତି ହଉଛି, ଆମେ ସେଇ ପ୍ରୋସେସଟାକୁ ହିଁ ଡିସ୍କସନ କରୁଛୁ। ଯେ science was considered as a fixed body of knowledge, and we are supposed to transfer the scientific knowledge or the facts to the next generation, to the learners. But now it has been shifted. That shift we are discussing. What are the shift? How shift has been occurred? Okay, so the fixed body of knowledge को हमें transfer करथुलु, हमें कहथुलु suppose गोटे concept କହିदेलु जे Boyle's law. So we are thinking that Boyle's law is there and we have to only transfer the knowledge. Students are writing the Boyle's law and writing in the examination. That was the previous process. Boyle's law को हमें मने रखिबा एती कथा हमहु जणा थिला, रिमेम्बरिंग रु आउ बदे उपरु को हमें जाउ नथुलु। So that is, but now this is a shift कथा हमें कहूछु जे केमिति चेंज होउची वर्तमान, तेन हमकु एज ए साइंस टीचर कोन करिया पय पड़िबो क्लास रे। ଆଉ ଏଇଟା ଏଥିପାଇଁ ଇମ୍ପୋର୍ଟାଣ୍ଟ ହବ ବା ଆପଣଙ୍କୁ ଜାଣିବା ଦରକାର ଯେ ଆପଣମାନେ ଯେତେବେଳେ କ୍ଲାସରୁମରେ ଟିଚିଂ ଦେବେ, ଆପଣ ଲେସନ ପ୍ଲାନ୍ ବନେଇବେ, ସେତେବେଳକୁ ଏଇ ଯୋଉ ରାଇଟିଂ ଅବଜେକ୍ଟିଭ ପାର୍ଟଟା ଆପଣମାନଙ୍କର ବହୁତ କାମରେ ଆସିବ। ଓକେ, ଆଉ କିଛି ଡାଉଟ୍ ଅଛି ଏଥିରେ? ଓକେ, ଥ୍ୟାଙ୍କ ୟୁ। ଆମେ ସେଇ କଥା କହୁଛୁ ଯେ ଆମକୁ ଦେଖିବା ପାଇଁ ପଡିବ ତା ପାଖରେ ପ୍ରି କନସେପସନ କଣ ଅଛି। ଜଣେ ଯଦି ଏଜ୍ ଏପ୍ରୋପ୍ରିଏଟ୍ ସ୍କୁଲରେ ଆଡମିସନ ନଉଛି 13-14 ଇୟର୍ସରେ ବି ଆସିକି ସେ ତାର ଏଜ୍ ଏପ୍ରୋପ୍ରିଏଟ୍ କ୍ଲାସରେ 8 କ୍ଲାସରେ ଆଡମିସନ ନଉଛି, ତ ଆମେ ଏଜ୍ ଏ ଟିଚର वी शुड नॉट थिंक दैट he has no knowledge, no preconception. He has so many preconception. That means up to age 14 he was working somewhere or doing something or coming across different concepts in different form. ଫର ଏକ୍ସାମ୍ପଲ ସେ ଯଦି ଜଙ୍ଗଲକୁ ଯାଉଥିଲା, ସେ ଯଦି ଜଙ୍ଗଲରେ ବିଭିନ୍ନ ଗଛ ପତ୍ର ଉଠଉଥିଲା, ତାହେଲେ ତାର ଗଛ ମାନଙ୍କର ପତ୍ର ମାନଙ୍କ ସହିତ ପତ୍ରର ସେପ୍ ସାଇଜ ଠାରୁ ନେଇକି ତାର ମେଡିସିନାଲ ଭ୍ୟାଲୁ ପର୍ଯ୍ୟନ୍ତର ଜ୍ଞାନ ହୁଏତ ତା ପାଖରେ ଥାଇପାରେ, ସେଟା ତାର ପ୍ରି କନସେପସନ ହେଇଥାଇପାରେ। ତେଣୁ ଆମକୁ ଏବେକାର ସାଇନ୍ସ କ୍ଲାସରୁମରେ ଆମେ ଫାଷ୍ଟ ନଉଛୁ ପିଲାର ଏକ୍ସପିରିଏନ୍ସ, ହ୍ୱାଟ ପ୍ରି କନସେପସନ ହି ହେଜ୍ and what we will give the students as the learning experience. Then with the combination of these two things the child will be able to construct knowledge. Okay, so the today's pedagogy gives value to the voice of learners and their questions, their abilities, their arguments, their justification. If they are thinking differently, then we have to accept it. Not like that you sit down, this is not in their book, this is not in their theory, because we know that the very nature of science is tentative in nature, so it may change. So we have to create scope for the learners so that they can argue, they can justify, they can perceive according to their abilities and their conception. Okay, and a collaborative approach କଥା ଏବେ କୁହାଉଛି ଯେ there will should be a collaborative setup rather than rote memorization. When you are discussing with some of your friends one concept, then it will be better learned. Okay, Okay, then pedagogical shift, the pedagogy which is used to construct knowledge through diverse learning strategies that include your previous experience of the learners, their socio-cultural economic background, their content knowledge. And the fundamental difference between acquisition and construction of scientific knowledge is passive receipt of knowledge and active involvement and critical examination based on critical thinking of learners. So again, the pedagogical shift is in those areas. The areas are the pedagogical shift in nature of science. କୋଉଥିରେ ଚେଞ୍ଜ ହେଇଛି pedagogyର shift କୋଉ ଜାଗାରୁ ଆରମ୍ଭ ହେଲା the nature of science ରେ ଚେଞ୍ଜ ହେଇଛି knowledge shift ହେଇଛି learners learning and teachers assessment ମଧ୍ୟ ଚେଞ୍ଜ ହେଇଛି साइंस करिकुलम साइंटिफिक इंक्वायरी प्रोसेस चेंज होती से प्रोसेस को एडवांस कराई साइंटिफिक मेथड टू साइंस एज इंक्वायरी इंपोर्टेंस ऑफ क्रिटिकल पेडागोजी वेरियस एस्पेक्ट ऑफ इंक्लूसिव एजुकेशन ये सब कथा केबे हिची ना आफ्टर 2005 रे तळे एनसीएफ 2005 आसला ये सब चेंजेस हिची ता व्यतीत याको आउ टिके मॉडिफाइड फॉर्म रे कुहाइची आपनकर नेशनल करिकुलम फ्रेमवर्क फॉर स्कूल एजुकेशन 2023 okay then what is the pedagogical shift in the nature of science so we know that our earlier belief what was our earlier belief was that no single method is there that can be termed as method of science but there are many features common to scientific enterprise that can be seen as scientific approach आमे एबे कहा को scientific approach बोली कहउछु ना हमरो belief थिला जे आमे जो मेथड रे साइंस पढौतुलु से जिंसो एबे शिफ्ट हेछि नेचर ऑफ साइंस रे आमे कहउछु जे there are scientific approach many features are common to scientific enterprise that can be seen as scientific approach and the tentative nature of science does not make it unreliable आमे एपटे कहलु नेचर ऑफ साइंस जेतबे डिस्कशन करलु आमे कहलु जे वन ऑफ द नेचर ऑफ साइंस इज दैट it is tentative in nature tentative means it is not fixed so you can have a question in your mind that if it is not fixed then why we will learn science why we can believe science why we will believe science okay so this is the tentative nature but it is not unreliable ये नुहे tentative हेतले भी unreliable नुहे किंतु आमे जेतबेले देखुछु जे elements of subjectivity या भितरे elements of subjectivity रहिछि but सबबेले आमे चाहुछु जे objectivity but it is accepted observation through रे scientific fact develop होछि scientific fact गुडा को पुणी चेंज होछि केमिति चेंज होछि ना फिर फर्दर रिसर्च फर्दर जस्टिफिकेशन फर्दर एक्सपेरिमेंटेशन ता ऊपर जेतबेले होछि से पुणी चेंज होछि सो इट इज टेंटेटिव आगुरु थिला क्रेब साइकिल ले केते 48 38 एटीपी बाहरला एबे को ना 40 एटीपी बाहरतला बदे एबे हेगलानी केते 38 आसी तेनो ए बळिया चेंजेस गुडा को आछि हमें केबे कहलु जे नै हमरो 9 प्लैनेट्स अछि पुणी कहलु नै प्लूटो इज ए डिफरेंट टाइप ऑफ planet so it is dwarf planet and now again it is included here all these things are happening so set by science को कहै science is tentative in nature okay but sako unreliable न तक हमें rely करबा but after time some time it may change Sitpen कहला science always strive for objectivity so socio-cultural factors have impact on nature of science in order to understand science we must know the manner in which knowledge is constructed over time as well as the method used to validate the knowledge and place of science in society. Then knowledge रो कौन शिफ्ट हेची ना knowledge रो शिफ्ट हेची जे it is shifted from a static entity to a dynamic entity. So knowledge is not a static entity actually. Knowledge static entity नथिला पूर्वरु कोन डिसाइड कराउतला जोटा हम डिस्कशन करलु एबे जे knowledge was considered to be a static entity and it need to be transferred to learner's mind and makes them a passive receiver of knowledge without engaging in thinking and questioning. Static entity ର meaning ହେଉଛି ଯେ ତାଙ୍କୁ ଆମେ allow କରୁନଥିଲେ କରାଯାଉନଥିଲା ଯେ ସେମାନଙ୍କର ଥିଙ୍କିଂକୁ allow କରାଯାଉଥିଲା ବା କ୍ୱେଶ୍ଚିନିଂକୁ ଆମେ ସିମ୍ପଲି କହୁଥିଲେ ଯେ ଗାଲିଲିଓ has given this concept mean this is true, you have no right to question on it. Newton has done this means this is true. But actually we have to, as a science teacher, we have to understand that this is the nature of science, that it is tentative. So you have to allow questioning and stimulate the thinking of the learners. But shift कौन है जी ना, learning cannot be imposed on learners. Okay. So learning can be done, or the knowledge is actively constructed by the learner and cannot be passively received. So learning is something done by the learner and not something that is imposed. And this is how the growth of scientific knowledge actually occurs. Actually, the students are allowed to observe, that is your observation, and observation leads to interpretation of data. To understand this, you can take some examples also. So when they will interpret the data, on the basis of how they will interpret the data, they will interpret the data on the basis of concepts and assumptions and inquiry. And when they will do this, it will lead to growth of scientific knowledge. But when these assumptions changes, then knowledge changes. This is the fact about science, that how the scientific knowledge grow. It represents about the growth of scientific knowledge. If you observe the nature, some phenomenon you may take as example and observe the nature. So after careful observation, repeated observation, or a number of observation, you interpret on the basis of your observation, you interpret your data, and on the basis of your concept and assumption, you grow your scientific knowledge. The next shift has occurred in your pedagogical shift in learners, learning and teachers. ସେଥିରେ କ'ଣ କ'ଣ changes ହେଇଛି? For an effective pedagogical design, a teacher has to take care of existing ideas of learners and the difference in nature of their ideas with the scientific explanations of those ideas. So some of the ideas are relatively temporary and unstable, but some of the ideas are also deep rooted, also well developed. So for an effective pedagogical design, a teacher has to take care of the existing ideas of learners. Learners ମାନଙ୍କ ପାଖରେ ଯୋଉ idea ଅଛି ତାକୁ ମଧ୍ୟ teacher ଦେଖିବା ଦରକାର, and the difference in nature of their ideas with the scientific explanation of those ideas. So the teacher should develop the habit of listening to the learners, and the teacher should also give value to their ideas and motivating them to bring their own ideas about their observation and interpretation of phenomena in their own context without demotivating them. So this is now the shift. So now the constructivistic approach you will follow in your lesson plan. So the learning of science must help them to nurture their curiosity rather than their ability to reproduce textual knowledge. And this shift is also necessary to make learning atmosphere conducive and learning more meaningful. Okay, so the learners as the process is changing, so there is also shift in assessment. So the as we know that what is the purpose of assessment? The purpose of assessment actually is to improve the teaching learning process. We know this. but we generally we were doing the evaluation process mostly when so we need to assess the or review our objectives that have been identified for different stages of learning and so assessment how assessment is changed. Now, after NCF 2005, our NCF 2005 recommended the shift in modes of assessment. So, by making it more flexible. And the NCF 2005 also emphasizes on various modes of assessment like your through activities, through experiments, through journals, illustrations, oral presentation, peer evaluation, self evaluation, group work assessment, models, portfolios, and other areas of learning because the purpose was to assess every area of learning. So, learners should be involved in the learning process and we have to provide as a teacher we have to provide support in each and every aspect. That's why assessment was made flexible and there is a shift in emphasis from testing rote memorization to understanding and application part. So this is the shift in assessment. We have now shifted from rote memorization to understanding application. If you are aware about the question papers of 2 days, then you can mark these things very clearly. That knowledge aspect is now shifted. And we have also shifted from the examination centered classroom process to learning centered classroom process. Our main motto is the learning so that we can achieve our national goal. Okay, another thing is there, but it is missed, I think. Okay. Another shift are the science curriculum and scientific inquiry. Science curriculum, I think we have discussed yesterday. So, what is the major shift? I will tell you some points. The major shift in pedagogy was that the teacher centered pedagogy is now changed into learner centered pedagogy and fixed design in the pedagogy is now changed into the flexible process. Before the teacher's direction and decision was final, but now learners are given the autonomy to think and to question. Teachers' guidance and monitoring of learning was there, but now the teacher's role is changed from monitoring to facilitation and mentoring and encourage the learning through support. Previously the learners were the passive receptors and now it has been shifted to the active participation in learning. And before it was within the four walls of the classroom, but now the pedagogy is shifted to wider social context and also beyond classroom, beyond textbook. Previously, it was a notion that the knowledge is given or it is fixed, but now the shift has been occurred and it is assumed that knowledge is evolved and created. Okay, another shift is there the scientific method and science as a inquiry process. So, scientific methods are the ways of thinking and inquiring that allows investigating and explaining natural phenomena and solving problems scientifically. So, a scientific method does not prescribe series of steps to be followed rigidly, but it says that the steps are flexible and dynamic. So, when the steps will be dynamic and flexible, then reliable evidence can be gathered. Okay, next we will proceed to the observation skill, process skill in science. So, we all know that we have shifted the pedagogy to different aspect, different area, and this pedagogy shift in the pedagogy gives rise to another area, that is the process skill, which was not emphasized previously, but now it has been emphasized. Why we will focus on the process skill? Why we will focus on the process skill? Yes. So the teacher, as we know that the if the process will not be emphasized, then science, the nature of science will remain the same. Yes or no? Previously, if you will look to the previous stage, the teacher was going to the classroom in a bare hand with a textbook, maximum a textbook. But now, when the teacher is moving to the classroom, then you can see the teacher is moving with all hands full of materials and all resources with him. Otherwise, science classes cannot be taken, because the teacher is now not aiming at fulfilling the or transferring the knowledge to the children. You will demonstrate and give them scope to observe something. Suppose you are giving one demonstration, or you have taken something so that the people will be able to observe the thing, then you should be first aware about the observation process. So what the student will observe, that as a science teacher you have to be acquainted very well what the student will observe. Now, observation for what? First, we have to see that the learners will be able to observe very minutely by using their all five senses. So, on the basis of this criteria of observation, you have to move into the class with the required objects, so that their five senses will be engaged. So, the teacher need to take objects or different phenomenons or events what is occurring around us in any form, he can take it to classroom, and the students will be allowed to use their all senses to collect information, and they will identify what is there in the object, what are the similarities in the object, what are the differences among the object or events or phenomenon. They will interpret the result on the basis of their observation. They will also recognize the order or sequence that takes place in a event. For example, here you can I can give one example to you. Suppose there is a chapter in the book of class 8 also, the reproduction in animals. reproduction in unicellular animals, reproduction in multicellular animals. Then the students might have the knowledge in the previous class about the unicellular, multicellular, or might have the misconception also. So while moving to your class, then you have to take sufficient supporting materials, like the materials may be any object, maybe any picture, or maybe some cards, maybe videos, maybe anything, whatever you plan to take into your class. And when discussing about the students and giving them opportunity, give them opportunity or allow them to identify the object, allow them to analyze this, or then they will interpret by their own what they perceive, how they perceive. That is different thing, that they will perceive how it is occurring. Suppose unicellular and multicellular organism, and you are giving them the pictures and asking them what they are observing. You are showing them the video and asking them what they are observing in the video. They will interpret from it what is their observation, how they perceive it. Is there anything in their surrounding like this thing? So they will relate it, so that we can say that the higher order objectives can be achieved. Otherwise, if we will say only the reproduction in animals, this is asexual sexual reproduction, and unicellular organisms are being divided as for example amoeba, it is divided into two different cells by using the process of binary fission, or anything you can teach like this, then the students will not perceive this. You have to take different materials so that they will perceive what is happening in the video, what actually how the amoeba looks like, what it does during the reproduction process, why it is called as immortal organism. So everything they will interfere from the observation. So observation is a very basic skill of science, basic process skill of science, that you have to adapt as a teacher in your classroom. So that you arrange your materials in such a manner that they will be able to recognize the order of events or the sequence of event that happens actually, and then only they will be able to relate it to the environment. If you are teaching them in this manner, suppose you are taking one using the ICT resource and taking one video of how amoeba is dividing into two new cells by dividing its body through binary fission, then they will observe it. Then you can provide them materials to organize it in a sequence, how amoeba is dividing to different organisms, different new organisms. Then they will do it by their own. Then you give them another situation or another video, like how hydra, one example of multicellular organism, and how it is dividing through the process of budding. They will observe it, then they will perceive, they will observe, then they will relate it in their mind to relate to the concept what is happening there in case of the multicellular organism. So then how the bird is growing, and how after maturation of the bird, how the bird is being separated from the main body of the hydra. So when they will observe this process, then they can be able to sequence it, sequence the events. You can then give them the materials to sequence what happens in budding process in hydra, what happens in the binary fission of the amoeba. So when they are able to sequence by themselves through different pictures it may be, but they will be able to analyze, they will be able to relate how the unicellular organism is doing and how the multicellular organism is doing. So what is the difference? If the multicellular organism is doing this, so who are the other multicellular organisms present in our surrounding, what they are doing, whether they are doing in this process as in hydra. So these things need to come to their mind. So if these things will come to their mind, if the science teacher will proceed in this direction, will work in this direction, then the students will be able to recognize the order or sequence the events. They can observe the details of an object or event. They can ask questions to get more information about the object. They can ask why type question, how type question about every event or phenomenon and relate it to the surrounding. What will be the benefit if we are talking about the constructivistic approach or the changing perspective, what is there in the science, or about the process skills in science? So what will be the benefit of this type of approach? The students will be benefited that there are, as we know, that there are our world is very vast. Okay, so there are so many exceptions are there in the world. So if you will we are transferring the knowledge, only knowledge, scientific knowledge to next generation, next generation, next generation, then invention is not possible. If we will not stimulate the thinking process, then invention is not possible and the society will not move forward. That's why we have to stimulate these things through the content. Our content is there with us. So through the content, we can stimulate this. Take another example. Suppose you have another example in your content, that is your physical resource and their utilization. So when you are teaching the physical resource and their utilization, so you should, as a science teacher, you should first focus on what are the physical resources that is with us. Generally what happened, the process actually happened sometimes, that as this is a generalized or environmental related chapter, then sometimes teachers do that this is a very easy chapter, so let the learners read by themselves and leave it. It is also happening. Okay, but here you, what you have to do, you have to first analyze whether this chapter, the physical resources and their utilization chapter, is there in your book, to read in the book only, or for any other reason it is there in the textbook. That you have to think as a teacher. Another example I can put here, that environmental education. You can see environmental education is introduced in our curriculum starting from class 1 to 10. Everywhere that is a emphasis on environment education. Why? To protect our environment. But what happened? The result is in front of us. That environment is being polluted more and more. We have a news recently that we are committed to make our environment and make our climate carbon free by 2070. But after that summit, it has been observed that it was in news also, it has been observed that the emission of carbon is being increased because we are not taking steps. And this is not the responsibility of one man or one government or organization, anything. It is the responsibility of every individual. So the teacher has to think about this point of view also, the physical resources and their utilization. If you are taking the chapter, then what you have to do, you have to first identify what are the concern, why this chapter is there. Then you have to take the experiences of the learner into the classroom in the constructivistic process. They will identify what is there in the in our physical resources, what are the different spheres present here, what are the components of each sphere, and how you will do with these components, whether these components are related to us or not, if these resources will be finished, then what we will do. So all these things you have to analyze first. Accordingly you have to connect it to their directly to their learning experience, to their daily life experience. You have to demonstrate the things, connect it to the daily life experience, allow them to observe what is happening in their surrounding. Actually we are moving here and there, but we are not observing, we are not being, our mind is not being stimulated to observe this our physical resources. So as a teacher of science, you have to stimulate it first. You go and you can give project work also here. You go and observe the physical resources, what physical resources are present around you in your surrounding, and make a list of it. Then make what are the sources, how it is used in your community. Then make a list, then come to class, then you proceed. You can proceed, you can sensitize. This is a sensitization type topic. So observation, for observation you have to stimulate your learners also. You have to stimulate them to observe. So many things are there in your surrounding, but you are also not observing. So similarly you also learn to observe, stimulate your learners to observe, so that the observation skill will be developed gradually. So the process skill, as process skills cannot come at once. You are teaching the physical resource chapter and using this thing, you may not expect that these skills will be developed after teaching of this content. No, you have to use it continuously to um, see the result, whether observation skill has been developed among the learners or not. And asking questions, ask questions to them. If you are giving them the task and your purpose is to develop the observation skill, then you have to ask them the questions about the objects, events, and phenomena. You have to frame such type of question to know whether they have observed it properly or not, how they have observed, how which senses they have used to observe the phenomenon or event or object. And also as a teacher you have to identify the questions which they have to answer by their own investigation, not from the Google. For example, suppose one event is there with me. Once I asked one of my student, how many times you breathe in 1 minute. Immediately she took out the mobile phone and go to Google search for asking that how many times we breathe in 1 minute. So see what is the difference in our society. So as a science teacher, this is now our responsibility. This has become our responsibility. Simple question, we are breathing every day, every moment, every fraction of second. But when I have been asked a question, how many times I breathe in 1 minute, then I have to go to the Google search. This is happening with the children now. So you have to be aware about these things as we are in living in a different century, that is 21st century or anything you can say. So you have to identify the question which can be answered through their own investigation, not from Google or not from anywhere else. You give them simple questions related to their community or their surrounding, what is there, how, suppose in the physical resources there is water also. So you can ask them, what are the water sources around you in your community, how the peoples are using the water sources, what sources are there in your surrounding. They will list it out, not that what is there in the film or movie or in Google. What is there with them, they will list it out. Which sources you use for drinking water, which sources of water you use for your washing clothes or etc. So similarly you have to design your questions in this manner so that you can identify that whether it is the own observation or this is from Google or this is from this is a copy matter like this. So they, allow them to do something. And you, as a science teacher, you should develop some critical questions also. So different type of question you have to take care of different type of questions so that you can stimulate the process skill, the observation skill among your learners. So for criterion, so you have to design simple questions to know which question to know about their investigation. You have to develop question to raise their critical thinking, critical question you need to develop, and for their critical thinking also you have to develop some questions. Similarly, this is the observation skill. So if you want to develop it, so every concept in every part of the science textbook, you need to inculcate or take this skill as a outcome of your class, so that the students will develop observation. Then next is your classifying is another skill, process skill. Classification, experimentation, all these things are also the process skill. So for if you want to develop the classification skill, so classification comes after observation. If the students will not observe how they are going to classify, they will not be able to classify. They are linked. So there is another term also there in science. They are called as strands of science. These strands are like a rope. If you want to achieve or develop some skill, then you have to develop the another skill. Otherwise, you cannot develop one skill singly in a single manner. You have to, you can they are attached like a strand of a rope. ରୋପ୍ରେ ଯେମିତି ଗୁଡ଼େଇ ଗୁଡ଼େଇ ଥାନ୍ତି ସେମିତି ଷ୍ଟ୍ରାଣ୍ଡ ଭଳିଆ ଏମାନେ ମଧ୍ୟ ସେଠି ଲାଗି 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 ହେଇଥାନ୍ତି। ଅବଜର୍ଭେସନ୍ ନହେଲା କ୍ଲାସିଫିକେସନ୍ କରିପାରିବନି, କ୍ଲାସିଫିକେସନ୍ ନହେଲା ଏକ୍ସପେରିମେଣ୍ଟେସନ୍ ପାଇଁ ତାକୁ ପ୍ରୋବ୍ଲେମ୍ ହେବ, ଏକ୍ସପେରିମେଣ୍ଟେସନ୍ ନହେଲା ତ ତାକୁ ଡାଟା କଲେକ୍ସନ୍ ପ୍ରୋବ୍ଲେମ୍ ହେବ, ରେକର୍ଡ଼ିଂ ପ୍ରୋବ୍ଲେମ୍ ହେବ। ଏଇଭଳିଆ ସବୁ ସେଗୁଡ଼ା ଷ୍ଟ୍ରାଣ୍ଡ, ଦେ ଆର୍ attached like a strands. So if you want to develop the skill of classifying, then you give some types of questions like identify the similarities in group of objects, identify what are the difference in the group of object. You can take pictures and ask them differentiate between these two pictures. In this example also, for pollution chapter or natural resources, what is there in your content, you can also take this type of thing so that they can classify. You take the pictures of one polluted area or non-polluted area or video and ask them to observe what is happening in the polluted area. What are the difficulties? What difficulties they are facing? What is the difference? So you can do all these things like this. Then grouping the objects on the basis of characteristics given at a time. You give one, take a picture. On one picture you can develop so many skills also. In one video you can develop so many skills also. You give them one characteristic, on that characteristic, that basis you identify these things, on that basis you group them, on the basis of another thing you can take the example and identify this. So if they are they will do this continuously, then the process skill will be developed. Otherwise process skill will not be developed. Interacting with the teacher for some instruction, if they will interact with teacher, how they are going to interact, how systematical they are interacting, following safety measures while working in the laboratory. So when to perform the activities individually or in group in a systematic manner. Suppose you are teaching the chapter I and they are asked to label the diagram of I. Suppose in one learner label first the retina, then the lens, etc., in a haphazard manner. So this is not the systematic process. This is not the not helpful to develop the skill of the process skill of the learner. So first you have to make it a systematic thing. The first either you go from outside to inside or come from inside to outside, so that it will be a systematic process. So these are the classification skill. For developing classification skill, you can do this. And similarly, experimentation skill you have to, if you want to develop among the learner as a process skill, for experimentation, you have to list out the process. What you will do, what activity you will do, so that experimentation will be fruitful. Even now, it is observed that in so many teachers this experimentation skill is not found. When they are doing the experiment, they throw the apparatus here and there, they put it in different places, so they unable to handle the apparatus properly, or breaking of the glass apparatus due to the carelessness, or some these things happen during the process of experimentation. So if you want to develop the skill of experimentation, what you need to do, you need to be systematic, to ask the students to systematically do things in a stepwise manner. Suppose you want to do one experiment on the presence of chlorophyll in the leaf of the plant. Then what you will do, you have to explain the process systematically. This is the step, these are the steps. Step 1, you have to identify one healthy plant and the one healthy leaf of that plant. Then you collect the black pepper, then you go to that plant and put the black pepper on it systematically, leave it for 1 day. Then after that you on the next day you prepare a iodine solution and put it, bring the leaf to the laboratory and put it there and observe what happens. So these are the systematically the steps are organized. So when the steps are systematically organized, then they will and ask them to follow the steps, not that first make the iodine solution, then go to the garden, then identify a leaf, not like this. System means you have to follow the steps appropriately, so that the experimentation will be performed successfully. So when they will do in this way, they will plan first, then they will bring the required materials, then they will do the experiment. Similarly, if you are doing a laboratory experiment, then you are first you have to write in one paper in your copy that what are the materials required, what is the requirement for this experiment, and you have to list out the apparatus, what apparatus I need for this experiment, you have to list out. Then you have to collect those apparatus, those solutions, and keep it well arranged on the table, so that there will be less chance of breaking of the apparatus. So if you will arrange it properly, then another principle is there, you use you use the apparatus systematically. Generally what happens while you are doing the experiment, you have to put the apparatus to be used on the left hand side, and after use the apparatus are placed on the right hand side. That make it a principle. So the student will also do like this. Suppose you are pipetting something, so this is the used pipette, so put it on the right side in a particular place so that you can use it for that particular solution. This pipette can be used. So these are the skills of experimentation, and these skills are nothing to do with the experiment but or something to do with experiment, but this is a process skill. You have to develop it. If you will work in such a systematic manner every day or in every time, then the skill of experimentation will develop among you. Okay, so then another process skill is there, that is your collection and presentation of data. While you are experimenting, you have to collect and present data, or recording and reporting of data is also a process skill. So how you will know that the students are developing the skill, process skill of presenting, collecting and presenting data? So when you ask your students to go take the same example of physical resources in your surrounding, you are asking your students to collect data from 2 to 3 communities of their surrounding about the resources used in their community. So how they will collect the information, you can ask them to discuss among each other first. Then they can develop a systematic format or a plan they can do to collect data. And with that plan or that appropriate format, they need to go to the community and collect the data in that format, so that the skill will be developed among them, that how to collect information from the surrounding, from the community. Then when they are collecting, after collecting they have to present the data. Suppose they are collecting the data like this, the water sources of our community. What are the water sources, how many families are living in this community? So they went to family 1, then what are the water sources they have written, how many sources they have written. So similarly they have listed 15 houses of their community, and the sources of water what the communities are using, and how many sources they are using in the community. So that data they have collected, but how to present this data in the class, how they are going to present this, so that skill need to be developed. They need not to present like this, that I went to house number 1 and see that they are using the tap water and pond water, they are having a bore well. So they have 3 sources of water, and in second house I found this, fourth house I found this. So this is not the presentation. So they have to organize it. How many houses are using borewell? So he can present 4 houses are using borewell water for drinking, washing, cleaning, etc., etc. And 5 houses are using pond water for washing clothes, and borewell tap water, PSD, PWD water for their drinking water or for their regular use. And these other 10 houses, they are using this source of data. So this is the way of presentation, how they are going to present the data. That skill you have to look into the students. Then recording and reporting of data. So this is data recording and reporting, how they are going to make a report So they have to identify different aspect, different whether they have to make tables or they have to make graphs or they have to make pictures, or similarly in this way they will choose in what way they are going to present the data. So these are the for these things the teacher has to plan previously and in a proper way. That thing can be done by a science teacher to develop this skill. Then another skill is important skill, most important skill, and this is not for science teacher only. This is for all teachers, because this is an important skill, that is your communication skill. So communication skill, as we have discussed in the previous example, communication skill is how you are presenting. So presenting skill is there. That means you have to develop your communication skill. So communication skill, suppose you want to place your opinion, then how you have to communicate. When you want to present the facts and hypothesis, then how you will communicate. So these are the skills of communication. So you have to distinguish between the opinion, fact, hypothesis. You have to express your ideas in your own words. The listening and responding to others' ideas in the group. These are the part of communication skill. You have to work on these skills. So accepting feedback from others and appreciating that others may have a different point of view. So you have to work in this way also, accept the feedback from others, review one's ideas according to feedback given by others. You have to define the situation or events in your own language. Then you express your thought through various channel. So you have to make your student understand, and what you have to do as a science teacher to develop this communication skill as a process skill, you have to give them chance to express their opinion, their facts, what hypothesis they have made. So or you can give them chance to, you can quiz, take a quiz, help of quiz or poster, debate or drama, or you can use worksheets, or you can use quick test also. So this type of skill, process skill, can be developed. Then another very important process skill is there, that is your explanation, explaining. As we know that in every aspect, everywhere we use the word explain for understanding. If you want to know whether the child is understanding or not, whether he understood the concept or not, then you we write the objective as the students are explaining the concept, explaining the process of uh, photosynthesis or reproduction or circulation or everything. You are writing like this, they are explaining. But what are the skills, how to develop the skill of explaining? Now you have to uh, first observe. If you want to develop the skill of explaining, then he has to observe it. Then he has to make hypothesis like this, what are the possible solutions, how the procedure may proceed, all these things you need to explain. Then establish the relationship. Suppose for example, let us take one example of circulatory system. So you have taken one objective, that explaining, the students are explaining the process of working of a heart. Then how the students will explain? They have to know the components, how they will relate. So the question is the how to explain the function of heart. Explain means first we have to identify what are the components of heart, how we will establish a relationship between these components, and these components, when we relate these components, then we can say there are veins, arteries, and a heart muscle, and bloods are there. and these are the components, how they are related. Some bloods are coming from upper end, from lower end, some are going from the heart to lungs or lungs to heart, like this they are moving. So I have to establish this relationship. I have to learn this, how to establish the relationship. Otherwise, I cannot explain. Okay. So recognize the need to test this explanation skill. If they are relating, they are explaining, they are able to explain. So they are relating. Again, they are putting some logical things there when they are explaining. They are taking some hypothesis also. They are validating the procedure, whether it is occurring properly or not. So when they are able to do all these small things, they will be able to explain. So in as a science teacher, in every class we have to focus on those skills, because in a class we are not simply focusing on simply observation or simply explanation or simply classification. We are at a time using so many skills, but we are using it every day. When we are using it every day, we have to plan that what skill I am going to focus more in today's class. So accordingly, I have to take the learning experiences. So then next is your drawing conclusion or inference. Inference is also a process skill. So how to draw inference? Suppose take the same example that the students are collecting information about the water resources from the surrounding, from their community, and they are presenting it to you. They are making drawing conclusion now. So how they will conclude? How they will infer on the basis of evidence gained from their observation. What they observe, what evidence they found, and how they are relating it to infer. And what is there in their book, and what changing ideas they got from the evidence. They have gone to the community, they have found that water sources are used by people like this, how they are wasting water or how they are misusing water, or where the water is being wasted in the community. So everything they have observed. So what ideas they got there? So the changing ideas, they need to focus. They need to relate these with evidence and what is there in the book. Then they have to treat every conclusion as a challenge, so that they will draw the conclusion. And they have to also predict what may be the possible cause of any event or phenomena. And they have to again connect all the all the connections between different components, or all the patterns. These are the sources, these are the use, how they are using, how they are wasting, and for what purpose. Suppose I am କହିଥିଲି ଯେ clothing ପାଇଁ, bathing, everything they are using. So in which case the water is being wasted, how they are using in bathing. So all these components need to be connected through a pattern. They will follow, they will identify a pattern where what is there. All people are using like this or not, all people are wasting by using a shower or not. So they have to establish a logical connection using evidence or pattern to make their prediction. So these are the some skills of inference or skills of conclusion. Conclusion, what the conclusion will include, how they conclude the statement, how they conclude their observation or experimentation, whatever they have done. So while also in the assessment, so these are the some of the process skills which need to be addressed in the science class. Okay, so in the assessment also, process skill need to be assessed properly. Okay, so suppose your process skill is your experimenting or collecting data, then what you will do, how you will assess this experimentation skill, whether the skill is developed among the students or not. You have to make your checklist, own checklist. You need to list out the behaviors or the skills of experimentation or data collection, and you have to check while the student will work with all these things. You have to put a tick mark, put a check on the list, whether after that you can find whether this skill is developed or not. These are the process skill. During process these skills are assessed, and if this is not developed, you will find that no, this skill is not developed, then you have to work on it again and again in different classes so that the skills will be developed among the students. So this is all about your process skill in science that need to be addressed by the science teachers. Okay. Okay, this is all about your learning objectives and safety